Hello and welcome to a special episode of the ARM Viewpoints podcast series. I'm Brian Fuller, Editor-in-Chief at ARM, and in this segment, we're going to hear a special conversation between Paul Williamson, ARM's SVP and General Manager for IoT, and Chris Rommel, EVP of IoT and Industrial Technology at VDC Research. In the conversation, they'll discuss why Edge AI is a major inflection point for embedded systems and how developers are adapting, the rise of Linux and Python in IoT development and what that means for software tooling, how ARM's broad portfolio and partner ecosystem are helping OEMs deliver smarter, more scalable edge solutions, and what engineering leaders need to do to future-proof their software and system architectures for AI innovation. Let's dive right in.
Hello and welcome to our webcast, Accelerating Edge AI Innovation. My name is Chris Rommel. I'm the EVP of IoT and Industrial Technology here at VDC Research. And today I will be joined by Paul Williamson, who's the SVP and General Manager of the IoT Business Unit at ARM. So before I go any further, just want to provide a little bit of background for those that aren't familiar, tell you who VDC is and what we do. So we're the leading market research consulting company focused on systems engineering and the embedded technology market. And we've been tracking the requirements and preferences of that global community of engineers for over 30 years. And today I'll be sharing the results of some research we conducted sponsored by ARM, in which we captured the insights from over 275 engineering professionals. And from that research, we can offer some insights into the leading business and technical trends that are impacting development organizations today, as well as some of the best practices to address those trends. And over my time at VDC, I've seen the market hit various points of inflection. At times when key trends converge and really challenge the status quo. And now is no different. And this is really one of those times. And that new trend, that new change, it's Edge AI, that it has become a new frontier for differentiation and is really pushing development organizations to adapt and really evolve more rapidly than they did during what we were looking at just a few years ago in the rise of IoT. That its systems are becoming more intelligent, running more sophisticated workload. But all that said, with what is really a universal recognition of the need for Edge AI and the capabilities around it, is the fact that that transformation to Edge AI and its capabilities with it, it's uneven. There is a range of different maturation of engineering organizations. And it's really pushing a number of engineering organizations into uncharted territory. They often lack the resources or expertise to efficiently bring new solutions to market. And on top of that, many of those organizations, they still have those same traditional requirements for compute and the design requirements, be it real-time requirements, security, safety critical. Those are all still there. But the pursuit of Edge AI, which you can see even on with the huge jump in 3 years on the chart on the slide, it also brings with it new challenges. It requires a reevaluation of your existing tools, your components, the resources and human capital you have at your organization. And in fact, that survey I mentioned showed that next to cost, actually lack of experience is cited as the top issue that's impacting software and system development. And to give a brief example of some of that intersection of change and skill set gaps, as part of this research, I spoke to an engineer in the agriculture industry. It was a really interesting anecdote. Interestingly enough, they designed a machine to drive cacao, the key ingredient in chocolate. And the machine they were building uses a combination of hardware and software and machine learning to monitor and control the drying process of the beans, looking at everything from temperature, humidity, and rotation. And to me, it was really interesting from a couple angles. Well, first of all, from just a hardware perspective, they were using a 32 ARM-based MCU for some of the sensory inputs and motion control, and then a more sophisticated ARM-based SoC separately running Linux for the more high-performance, AI, ML application. And for software development, then the company used both C, which they had a lot of experience in for programming for the MCU, and then Python for the SoC. And here's where it's pretty interesting. I think it's a really cool commentary on the state of the market. Is that as part of this development, it was really a process of learning for this organization, because they said they didn't have a lot of background in this arena aside from recognizing a need. And they recognized then and admitted they had not yet really fully optimized machine learning and the integration of some of the libraries like TensorFlow. but they were talking about already for the next project, actively looking for ways to improve. And so to me, I think that's ideal where you are striving to innovate, pushing your organization and its comfort level, but you still recognize that you and your team need to do better. You need more emerging skill sets and new solutions to help you get your ideal product to market and continue to innovate. Uh, Paul, how does that anecdote and this data resonate with what you're hearing and seeing in the ecosystem and how you're enabling it?
Yeah, thanks, Chris. It's a great anecdote, and I think some of these use cases are really informative. I mean, we at Arm have to look 5+ years into the future to understand really what are going to be the needs of developers to land the key workloads they're going to have in that time frame, and how do we serve them best. And we've been seeing this growth of using AI and AI tooling to solve compute problems at the edge for some time. We've had to react to that. We've tried very hard to ensure that we're doing so in a way that layers the technology into the existing compute platforms in a way that is familiar and accessible to developers, whether that be sort of the improvement in sort of AI instruction operation, even on our CPUs in our A-class products, or as you pointed out, bringing sort of A-class and Linux-based development down into smaller form factors. So the launch of our V9 Cortex A320 to allow you to run Linux on smaller and power-efficient systems, through to things like embedded neural processors. The world is becoming somewhat heterogeneous, and as you've mentioned, that presents a sort of developer challenge. How do I most efficiently run my AI algorithm? So building things like our Ethos U NPUs, which are sort of deployed in these embedded microprocessor systems and microcontroller systems, and making sure that the software tools allow the developer in their normal flow to deploy an AI algorithm efficiently into one of those end devices. Those have been key focuses for us. And I think sort of align with what you've heard both anecdotally and somewhat in this survey, with the growing importance of, being able to deploy AI as a key workload.
Right. No, that makes a lot of sense, and it's good to know you're seeing those same things too, and are making the investments to help your customers adapt to that as well. Uh, so for years, looking at the IoT and embedded market, it was almost defined by its fragmentation. That was really the unifying theme, where you had diverse systems and form factors, configurations, and different operating requirements that created an ecosystem of highly specialized solutions. And that certainly is still the case in many ways, and nowhere was that dynamic more apparent than within the OS landscape. We had dozens of different operating systems designed to meet very specific sets of requirements and resource constraints, or performance. But now what we've seen, and Paul just touched on this a bit, is that these new requirements for advanced functionality and edge AI are driving the adoption of rich operating systems. And open source operating systems like Linux have gained an increasing adoption in the embedded marketplace. So you have that combination of increasing contributions in the Linux kernel towards the real-time domain, a maturing ecosystem of solutions and experiences at many engineering organizations really have helped push Linux adoption to new heights. And now, in fact, over 50% of IoT engineers that we surveyed said they're planning to use an open source operating system in 3 years. And that's as a primary operating system. Again, there's still very much a need for other options, and those multi-processor systems like the one I described before is a great example of where you can see that. But it also shows the shift and some of the important new considerations and best practices for engineering organizations making this shift, or even looking down the road and recognizing a need for edge AI and thinking about what that means for the runtime down the road. Ultimately, what we saw stand out in the data when we asked those folks that were then moving to adopt a rich operating system when they didn't have one in the past, it became very clear that tooling support is paramount. They have to ensure both optimization for their new target hardware as well as efficient software development for these next generation workloads. And OEMs can look to a range of sources when they're thinking about tools. In addition to standalone tool providers and those provided by some of the OS suppliers as well, semiconductor ecosystem participants like ARM provide a range of SDKs for software and machine learning model development that can be a great head start as well. On that topic of software and some of the challenges, and this touched on with that point of recognition in kind of self-assessment that agriculture engineer was discussing with me. For content growth continues to be one of the most challenging and transformational issues that are facing those organizations. Code growth requirements go beyond just needing to scale internal resources. Clearly, I mean, that's always a big crunch when you just need to develop more faster. But today, you also have to think about what you're using to develop that software. I mean, and how that aligns with your organization's skill sets and some of the solutions you're using. For decades, embedded software development was mostly conducted in C and other lower level languages. Now, however, embedded engineering, as we discussed, is no longer synonymous with just small footprint, fixed functions, or single purpose devices. Today, when you think about edge AI systems, particularly, they need to perform multiple sophisticated points of functionality. They have multiple processors or cores, and the requirements for that edge AI and the ecosystem around it, and the libraries have that people want to tap into. They really have recast the languages of choice that are needed for this next step in innovation. For example, around AI, we've seen a rapid increase in the use of Python, as well as other languages that are targeted at heterogeneous compute or HPC like Julia or MATLAB or R. And it's changing many organizations' needs then on the back end. Plus, the added thing now is, as I noted, they're no longer fixed function devices. You have an environment in which it's become an expectation then that software is going to continue to evolve post-deployment. And that brings with it even greater challenges and need for change in how one thinks about their software development and the organization that supports it or their solution development. Ultimately, for many organizations, the status quo no longer suffices. And in order to build and deploy across a range of devices, engineering organizations must identify new platforms that can offer opportunities for integrations with things like standard AI frameworks, while also offering compatibility with legacy code bases and IP, and or additional opportunities for integration and synergy with hardware. Ultimately, these organizations are trying to do more. They need to use new platforms to do so. And so in order to do that, they need to look for partners that can offer solutions that help them bring more integrated solutions to market faster. Paul, when you think about the change in software, be it rich OSs or software development, how has that changed how you think about the market and what different organizations need in order to be successful?
Yeah, it's a good question. And I do think this is some of the most interesting insight that really drives our thinking at Arm. We've got almost as many people working on software, frankly, as we have on hardware and compute systems. And this trend in change has been happening for some time. We've seen clearly in the sort of era of connectivity becoming a bigger thing, more complex software stacks emerging. But particularly as we move to the sort of edge AI challenge, the challenge around handling more data in these more complex systems has changed some of the programming focus to these higher level languages. Now, the underlying need for those real-time control systems that you mentioned isn't going away. And, we do still see that consistent need for those deeply embedded systems for power management and for, real-time functionality. But to handle this data and generate these insights locally, we are seeing people push for Python and higher level languages, the use of richer operating systems to be able to handle the scale and volume of data involved. And that means we've had to respond to that with also our hardware roadmap, but our software and tooling support we put into the ecosystem to enable this. So a lot of our focus on our heterogeneous accelerator has been around bringing in, PyTorch, ExecuTorch support, for example, or our Clyde libraries that allow people in embedded Linux to be able to deploy AI efficiently on the underlying hardware. So a big focus for us on, meeting the need this trend is signaling in the growth of the use of languages like Python. And we see that as being driven by this need for AI data. So a strong alignment with what we've seen in discussions with our partners.
Great. But let's take a step back from software for just a minute, as important that is. I think it's important to recognize that the edge AI processing landscape is incredibly diverse and complex. And with that, change is underway in the ecosystem. And highlighting some other, I think, really interesting research from the survey we conducted, you can see the standing of some of the different architectures as engineering organizations think about the next generation of the designs. And probably no surprise to many of you is that given all this change in the ecosystem, it has continued to make progress and innovate. And it's come to represent the leading choice among engineering organizations. Not only is it already cited by over 50% of engineers we surveyed as their primary architecture for their current project, but when we asked them what they expect to use on a similar project in 3 years, over 2/3 of them said they expect to use ARM. And ultimately, when I think about those results, what that means to me is that no one can really afford to lock themselves into closed platforms that risk limiting corporate agility or innovation. With a platform and a portfolio that really scales from those smallest footprint MCUs to highly performant CPUs, GPUs, and MPUs, ARM presents the ecosystem a range of solutions to both the semiconductor suppliers as well as the OEMs alike. And that portfolio breadth is very important because of the increasingly complex systems that we mentioned, the SoC's need for support those next generation designs. More organizations look to incorporate different types of accelerators for those advanced workloads. Another example, it's not shown here on this slide, but the use of NPUs like ARM Ethos is expected to nearly double in the next 3 years. So all of these different options and there's other things out there, obviously, but it shows me that it's critical, and many organizations are recognizing a need for both the NSYS performance and efficiency, that they need to look for new solutions, kind of the best in class, what they see around semiconductor technology, but then tying back to, again, what can help their organization meet their goals and do so with the best operational efficiency for the developer perspective as possible. And that ties back to another conversation I had with an OEM as part of this project, where we was talking. The person was in the medical field, and they were developing a new eye tracking system that provides assistive typing technology to people with disabilities. And it had been an old platform or technology that hadn't been updated that much recently. And they wanted to leverage some of the newest technology that was available and create a new long-term platform for their future product development, all with this goal of aiming for their solution to reduce its cost, its size, and also the noise that it made compared to previous versions for the sake of usability within their community. And in order to address those more complex requirements, the new eye tracking system they were designing, they decided to use an ARM-based processor instead of or replacing what was a series of 8-bit microcontrollers in that old design. So this new design, it allowed for not only more processing power and integrated features, but it also helped them reduce the complexity of their system and also reduce the bill of material in terms of hardware costs. So I think that was a really, interesting example where there was this, a recognized need for change at the organization. Engineering organization then saw there's new platforms available that could meet a number of needs. And then at the end result, they actually got something not only simpler, but could save hardware costs for the organization as well, all providing a foundation for not only their current product, but future generations to come. Paul, as you think about how the ecosystem has been changing and some of these architecture shifts that the engineers we surveyed were seeing, I mean, how does that resonate with you in terms of what you've seen in your own shifts in the ecosystem?
Yeah, thanks, Chris. I think I love the sort of wording used there of platform, and it is we try and think about this as a platform of innovation, and I think in those embedded use cases, I mean, clearly it's really reassuring and positive to see that sort of growth in the use of embedded accelerators like Ethos in these designs. And it speaks to the need of being and the ability to solve really interesting, challenging problems with something that is that sort of flexible platform. So by embedding that capability, it sort of provides you that scalability of future capability, but also doing it in that real power efficiency and cost efficiency for your future platform. I think almost more sort of striking for me is this drive to these higher performance systems as well. And the stat there you have for the growth in future design of ARM into these embedded systems. And I think it speaks to what we're seeing. We have this community of over 20 million software developers, and they're moving workloads and software from cloud to edge. And so some of these applications are having to manage both, and having this common software footprint across that to deploy in these edge nodes based on ARM, but having access to silicon that targets their specific needs, that flexibility in the edge, coupled with that common developer channel to the increasing use of ARM in the cloud, really reinforces that sort of value to the ecosystem of the ARM platform, and seeing that sort of reflected in people's perception of how they will use the technology is really great to see. So I'm, pleased to see we're going to see, more performance systems leaning towards ARM in the future because of those factors. So yeah, it aligns closely with what we've seen.
Great. With increasing software complexity and some of the scarce development resources and ultimately some more demanding end user requirements, I think we've already established that it's challenging engineering organizations to adapt. You have these exploding code bases, new functionality requirements, and everyone needs to try to find ways to simplify and accelerate software development. And to do so, it's very important to try to recognize what those key choke points are on edge AI development resources and productivity. And reflecting back on some of this research, when we asked developers and engineers what the most important characteristics were on their edge AI projects, um, software development and the ability to abstract code, it was cited as more important than power or performance. So as important as processing elements are, they themselves are just part of that equation. And again, it's important to think about what are those things that you can do to identify ways to reduce complexity, accelerate development process. And to me, that really highlights the importance of identifying whatever solutions there may be in ecosystems of centers of gravity that can help organizations be successful in that regard. And to address next generation edge AI requirements to that end, engineering organizations, you really need to look for those tools that can speed their development and offer that level of optimization for whatever next generation hardware they may be using. And many organizations, as we noted, can and should look at the semiconductor and semiconductor IP organizations like ARM and its licensees as a first step for the development solutions. And as part of this research, we asked organizations to kind of rank and rate some of the different sources of solutions that are out there. And ARM actually is in the survey was recognized as the clear leader in providing edge AI software development solutions. And while many different vendors have other helpful tools and solutions out there, ARM was actually consistently rated higher than its peers in this research. And in fact, for some of these, you can see it's effectively cited at rates 50% greater than its closest competition. Again, I think that's really interesting from a couple perspectives. One, I think it does reflect ARM's long history in providing leading development tool technology, everything from Kyle, which it's invested when it launched its M-class processing, to when it launched virtual hardware platforms, to its recent V9 Edge AI platform launch. The combination of ARM's history with it and its unique ecosystem position to its consistent investment and recognition of the need to invest. I think that's put it as a position where it's a widely embraced IP provider that also can offer these software design capabilities to the ecosystem to ensure that everyone can be as successful as possible in trying to bring these more sophisticated edge AI applications to market, not only now, but in the future. And Paul, as you think about the results of this research, as well as the own investments that your team and ARM are making in this ecosystem, how does this make you, I guess, reflect on that as well as plans to help the ecosystem in the future?
Yeah, really heartening to see the numbers here. And as you say, it's something we've done for a long time. Yeah, I think Carl now is something we've been investing in for 20 years. And we are continually evolving that as well as expanding the support we give into the ecosystem. So, one of the things I also recognize in looking at this is a lot of the work that we do at the foundations is supported by our partners who build solutions on top of this that expand the applicability of ARM's offering into the broadest possible range of software solutions to give our partners, the ability to build really compelling products. But we do continue to focus on it, whether it be, taking our partnership with Kyle to bring it to working with GitHub to ensure people can use modern developer flows, to areas of investment like Light RT and PyTorch, and making sure those land efficiently, whether you're using the CPU or an Ethos NPU in your developer flow. We have to think about how do we react to the changing needs in the market, and how do we continue to support with the base platform, with the work we do here at ARM, and the partnerships we build to make sure we're meeting the needs of developers for the long term. I'm always touched on, there's a lot that is changing for exciting reasons around Edge AI, but there's also an underlying need for long-term trust and stability of the tools. So, the Kyle investment has been one that has taught me a lot about the long-term trust that is placed in us with these tools, to allow a professional to, build a system and to be able to come back and modify and improve that system over time, and providing that consistency across silicon platforms and performance points is really critical to what we do. So, heartening to see it recognized, and something that we continue to look at. Where do we invest next to meet this edge AI wave and this desire for higher performance Linux open source based platforms, which changes the metric a little bit from the constrained embedded RTOS. So you'll hear more from us. We're absolutely looking at this space, Chris, and pushing forward to make sure we support these new capabilities.
Well, that's great to hear. Obviously, our research confirms what I think a lot of people know, believe, and expect from ARM in terms of its leading positioning, helping engineering organizations try to address their next generation requirements, whether they're edge AI or otherwise. But I do think it's clear to think and reflect that edge AI generally, it's in terms of impact today, it's rendering many organizations and the incumbent engineering technologies and design processes they're using is insufficient. But now we're in a situation where, in many cases, technology that was first deployed and developed for client enterprise systems, whether it's from GPUs or programming languages like Python, it's providing a new catalyst for the industry and a mechanism for rapid evolution. Already, the growing role that software plays within electronic system functionality and differentiation has it upturned a ecosystem traditionally averse to change. Look at many of the safety critical industries; those traditionally have been very slow moving. And while many of those requirements we discussed, whether it's real time or otherwise, those are unique and to a degree inelastic. Others, such as connectivity, enterprise integration, security, and AI, those are becoming much, much more important. And the fabric for continued edge innovation really, it's woven together by the different choices that are made on the software side, and the things in the different hardware components below that. As it pertains to software, OEMs face mounting pressure to design and deliver software as a seamless part of that overall system architecture. And again, need a foundation for that entire product lifecycle. And so, as an engineering organization, you need to think about what new solutions you need, how those address your evolving requirements, and how they hopefully can help you speed your development and time to revenue. And we just, obviously, there are a couple different examples we've talked about a few times. Open source and other rich operating systems really kind of jump off the page in terms of the correlation with adoption around edge AI, with over 50% of engineers already planning to use an open source operating system within the next 3 years. And beyond just tapping into rapidly maturing ecosystems like that around Linux, it's really critical that organizations take steps to future-proof their designs and architect their systems with flexibility and evolution in mind. And that really makes them need to think about the pace of requirements change, not only now, but in the future, and how they need to think about building devices that are capable of that evolution, both in terms of the functionality it ships, as well as what can happen post-deployment. And with all those changes and choices that organizations have, and AI and ML advancement really pushing the edge, or pushing the skill sets and needs of organizations and the potential that they have for their devices, they these organizations need to look for things that are highly optimized for those new workloads, those new optimized AI demands. And when they look then and recognize the value in those systems, it comes with a need to select a partner that's capable of providing the needed combinations of products, scale, and support. And ARM ultimately, through our research, proved itself as an example of that company that has built a foundation of products and expertise that can serve that IoT industry both now, in the past, and in the future. And it's been doing so for decades, as we've discussed. And with the complexity of those IoT systems on the rise for edge AI and other workloads, it's really important as an organization to think about that partner that can be someone you continue to work with, not only now, but in the future. And we've seen that reflected in ARM's continued advancement and investment in its IP portfolio, as well as its software development resources, and really positioning its customers and OEMs alike as having a trusted partner that can help them continue to innovate going forward. So, Paul, as we reflect back on the discussion today, some of the research that we conducted, what really stands out to you, or any final thoughts that you think our audience should have and take with them?
Thanks, Chris. Firstly, just want to thank you for the sort of independent insight you've here and bringing to life some of the real trends that you know that we see in this industry, and the challenges that are faced by developers. They're ones that I was hearing anecdotally, but it's great to see it in independent data. So thank you for developing that for us, and I know we're going to share that more widely. But I think you've picked out some of those key trends we're seeing, and at ARM, we're really committed to understanding how do we support this need for higher performance, these open source operating systems, and developers across the industry and their challenge to bring the benefits of AI to life. So we can, I guess, move forward knowing that we're doing something that looks to be needed, and further reinforcing the value we can bring with the ARM platform. So thank you for bringing us the insights.
Great. Well, thank you very much, Paul, for your time. This has been really interesting to look at the evolution of the edge AI ecosystem together. And we're certainly looking forward to more discussions in the future.